In task 2, you use these formulas up here for exponential growth and decay. And today we're going to add another variable, n, and we're going to be using it to compute compound interest in bank accounts. So we're going to be talking about money today. And so this variable n, you'll see it shows up there in the exponent. It's also there underneath the r, so you're going to have to use it twice. And it represents the number of times that the interest you receive on your investment is compounded per year. So when you give money to a bank or put money in the bank is going to pay you something for letting them use your money. That's called the interest rate. And it could be compounded once a year or twice a year or 12 times a year. And that number of times per year is the n value. So let's just go over all these different variables we see here. So A, again, is the ending amount, just like before. P is the initial amount or principal, again, just like before. R is not just the growth rate or decay rate, it is the interest rate. And again, it needs to be written as a decimal number, so you've got to divide by 100. And then here's the new one, N, number of times interest is compounded per year. And so we'll see a couple examples of that in a minute here. And then T is still time. So let's look at an example. Let's say you invest $750 into an account that earns 5.9% interest. How much would you have in 10 years if interest is compounded yearly? What if it is compounded monthly? So we've got our formula. And we're going to do this twice. So for the first one, we're talking about interest compounded yearly. So the question is, how many times in a year is a year? How many years are in a year? Well, there's just one, and so that means n is going to be 1 if we're talking about compounded yearly. So then let's plug in these values. So our initial amount, 750, and then 1 plus r, our interest rate. So remember, if you're not sure what that is as a decimal, you can always divide by 100. And so then we get 0.059. So that goes in place of r. And then the new thing, n, is just 1 in this case. And so then it's 1 times our time, 10 years, so 1 times 10. Now if you type all this in your calculator, one thing you have to remember, or else you're not going to get the right answer, is when you do the exponent, depending on your calculator, you need to make sure to put the exponent in parentheses. Okay? So I'm going to go ahead and plug this in. 750 times 1 plus 0.059 divided by 1. I don't really need to divide by 1. To the parentheses, 1 times 10 power. And so if you enter everything correctly, you should get $1,330, and I'm going to round up to 52 cents. Okay, so that's if it's compounded yearly. The second part is, what if it's compounded monthly? Well, how many months are in a year? There are 12 months in a year, and so that means n is going to be 12 for the second one. So we have the same formula, 750 times 1 plus same interest rate, but now we have to divide by 12, and then we have to put 12 times 10 in our exponent. And again, make sure you use parentheses. So when I plug this into the calculator, I get parentheses, or exponent parentheses, 12 times 10. You should get $1,351, and if I round up, 4 cents, which is pretty close to the first one, but it's a little higher. It's about $21 more. Because the interest is compounded 12 times a year instead of just once a year, you're going to get more money because every time it's compounded, that means the bank is paying you that interest rate.